cold donuts. Oh, oh, sweet donuts. Let's go down the street and eat more donuts. I want them now, especially the chocolate with the filler of donuts. Let's go and have some donuts.
Oh, I'm really hungry. I want
Let's
some
go.
donuts.
Yay!
Oh, got some donuts. Really hungry. Can't wait for the donuts. I'm hungry today. I want some donuts.
Hello! Welcome to the donut shop. So, do you guys want some free donuts?
Yeah, free donuts.
Well, you'll have to battle against each other.
Okay, yeah. Donuts, 3 donuts.
So, to win these donuts, you have to answer a math question. There are 3 rounds for this math question. And the math problem is, let R be the shaded region bounded by the graphs of y equals square root of x and y equals e to the negative 3x from intersection point T to the vertical line, x equals 1, as shown on the figure on the right. So for the first round, you will have to find the area of R. Begin. All right, time's up. So, contestant number 1, what did you do to get your answer?
So first we'd have to find what T is, the intersection. Obviously that looks like it's around 0.5. So using my intuition, I put T equals 0.5. In order to find the area, we need to find the area between the 2 curves. So since y equals e to the 3x is closer, it goes first. Then we subtract it from y equals the square root of x because it's farther from the x-axis. After I plug that into my calculator, I get area equals negative 0.37318.
That's so wrong. First, you cannot assume this number. And second, this part is wrong. And third, you need to put dx always on the problem. And look at what you get for your area. How can area be negative? This is how you do it for real. First, you need to find the T point. For T point, you need to use the graphing calculator. First, you put the first equation and the second equation. By the graph, you find the T point is 0.2387734, 0.4886604. And then since y equals to square root of x is farther, so in the integral of this area, this goes first. From t to 1, square root of x minus e to the power of negative 3x. And you need always to put dx at the end for the equation. And then you plug this equation to your calculator, then you get 0.442. And this is your final answer.
Good job, Joyce. So now, we're going to go on to part 2, which is you have to find the volume of the solid generated when R is revolved about the horizontal line y equals 1. You may now begin. They're so hot. Oh wait, time. Alrighty, so please show me how you got your answer.
Okay, so first in order to find the area of R, we have to see what shape it makes when it revolves around y equals 1. The shape that it makes is a donut shape, and the donut shape is 2 circles, so we have to use the equation pi r squared. So we have to find the integral. We take the pi out of each of the equations, and we subtract the first equation, since Joyce said the first time, is the square root of x minus e to the negative 3x. We square both of these, and dx. The final volume we get is negative 2.56753.
This is a donut shape, that's right, and it's pi r squared. However, for this equation inside the integral, you need to put this one first and this one second. and your volume will never be negative answer. And this is how you do for a real donut. This is how you do for volume. You put pi at the outside and the integral from t to 1. And you use 1 minus e to the power of negative 3x squared minus 1 minus square root of x squared, and then dx at the end. You use 1 because y equals to 1, and then e to the power of negative 3x is because this curve is further to the line of y equals to 1. And for this part, you get the outer side of the donut, and for this part, you get the inner side of the donut. And you use this outer part to minus the inner part, and you get the volume of this donut. And then your final answer will be 1.423.
Well then, good job, Joyce. You have won 2 out of the 3 rounds, making you the winner. So, what donut would you like?
I want that one.
Okay, I'll want this one. Yeah. Okay, here you go.
Thank you.
Congratulations. Come back to buy some more donuts later.
That was good donut.